Good evening, students. This is your favorite algebra teacher. We're on page 25. This is Algebra 1 on page 25. We're looking at problem 2. We already did the first one in class. We're looking at problem 2 currently. Now it says up here, shade all boxes with the x values such that g of x is greater than 0. Okay, well, we have all of these values here. -3, -2, -1, 0, 1, 2, 3, 4, 5. The g of x corresponding values is 2.4, 2.5, 2.2, 1.5, 1, 0.5, 0, negative 0.5, -1, and negative 1.5. So let's shade all boxes with the x values. Remember, it's the x values, okay? That is such that g of x is greater than 0. So where do we see g of x is greater than 0? Well, here's 0, and everything above the 0 is greater than 0. Okay, look at that. Okay, right here. X value is such that g of x is greater than 0. Right there. So these are the values that g of x is greater than 0. Here is 0. So it'd be everything above here. The x values, the corresponding values would be these right here. Okay? So I would shade this over here. I'm not going to shade it. I'm just going to circle it though. And you guys can still understand what's going on. Okay? Okay, let's take a look down here. Okay. So number 4, the graph of g of x is shown below, right there. Note, this is the same function whose table of values is provided in question 2, which is here. Circle the portion of the graph that shows all values such that g of x is greater than 0. Okay, let's do that. Now, when you take a look at this graph here, this is the graph of g of x. These are your x and y axes, so let's just mark it over there. Now the area of the function g of x, which is greater than 0, we're talking about the y values here, are these right here. Because it's above the x-axis, okay? However, the corresponding x values for that portion of the g of x is right here. It's not equal to 2, but it's less than 2. So it would be an open circle, and it would be running this way. The values of x would be like that. Okay? I hope you guys can see that. This is 2. All values of x such that x is less than 2. Okay? That would be corresponding to this g of x function. I'm going to turn the page now. Okay, this is the actual combination of the two charts, this one and this one here. Okay. Okay, actually, let me just fill in this one. I did it in class, but I'm going to do it right now again, just for the people who's on the computer. Maybe I'm not going to do that. Sorry about that. Okay. Okay, we're given the functions here. Let me just adjust this right here. So the functions used to create the table of values in questions 1 and 2 on the previous page are f of x equals 3x plus 7 and g of x equals negative 1/2 x plus 1. So these are our two functions right here. Let's see what kind of questions we have. When x is 0, right there, when x is 0, f of x is greater than g of x. That is true. If you can see f of x, the value of f of x is 7, the value of g of x is 1. So that is a true statement. You say yes. That is true. Explain how you can use the graphs above to support your conclusion. Well, we just did. The value of f of x would be 7 at x equals 0. The value of g of x equals 1 at x equals 0. Okay? So we have these 2 points that we're looking at here. Alrighty. Now for B, it says evaluate each function to verify that f of x is greater than g of x when x equals 0. Okay. So to do this, we're going to substitute some values in for the functions. So when f of x equals 3, and we're going to substitute 0 for that x, and substitute 0 right in there, okay? Okay, let's do that. You can already see that that's going to be 0. So the value of f of x will be 7. How about the g of x? I'm going to write it really small over here so it fits. The g of x is negative 1/2 x plus 1. I'm going to substitute 0 in for there. 0. And that'll just turn to 0. So over here, g of x would be equal to 1. And it is true. So we see at both cases, in both functions, when we substitute 0 in for the f of x, you get a value of 7. And when you substitute 0 in for x to the g of x function, you get a value of 1. So it is true, 7 is greater than 1. Let's check the other one now. Okay, moving on to C. When x equals negative 2, is f of x greater than g of x? Let's take a look. When x equals negative 2, the premise is f of x, which is this, greater than g of x? I see right here. Here are 2 points. Here are the 2 values of the 2 functions. Okay? So when x is negative 2, f of x is only 1. And g of x is 2. So 1 is not greater than 2. So the answer is no. The value of g of x is higher than the value of f of x at negative 2. Okay? I hope you guys can all read that. The value of g of x is higher than f of x at x equals -2. Boy, this pen is not coming out so clear, yeah? I hope it would be a little bit darker, but we'll see if we can hang on to this, okay? For D, evaluate the function to verify that f of x is less than g of x when x equals -2. Okay, let's try that. So when f of x equals 3, and what we're going to substitute -2 this time, -2. Okay, 2 plus 7. This will give us 6, -6 plus 1, it'll be 1. Okay. The g of x, I'm going to just write it down here. G of x is this value over here, -1/2 x plus 1. Okay. G of x minus, g of x equals -1/2 x plus 1. Now we're going to substitute the -2 in there and see what comes out. If we substitute -2 in for the x, -2 times -1/2 equals +1. This whole thing is +1 plus 1, which is going to make that equal to 2. So over here, 1 is less than 2. F of x is less than 2. One is less than 2. Here, look. Let's review again. F of x is 1. G of x is 2. 1 is less than 2. Okay, we're going to stop the video right now. I hope you guys picked something up right there. As you can see, this kind of work, it seems so simple, greater than, less than, and things like that. But when you combine it into functions and you try to see the value of the functions as systems, it gets complicated real doggone quick. So you got to pay 100% attention and focus. Okay? We'll be moving on to the next problem. Bye-bye.